So in this lesson, we're going to extend what we did with when we started solving quadratic equations in the last lesson in Goal 6. Okay, so we're going to look at quadratic equations that need to be simplified. Okay, so you should remember from the last lesson, standard form of a quadratic equation, ax squared, so something x squared, plus bx plus something x, plus c plus some constant, set equal to 0. Okay, so if you take a look at some of the examples over here, we don't have them set up that way, right? We don't have that equal to 0 on the right side that we need, okay? So the way we're going to handle these, step 1, we're going to convert to standard form, and the right side must be 0, okay? Then, step 2, we're going to factor the left side. And then, once we have it factored, like we did in the last lesson from Goal 6, we're going to use the zero product property, which says set each factor equal to 0. Okay, and we'll get the two solutions. They're also called roots to a quadratic equation. Okay, if we look at the first example, so we want this to be 0. Okay, we want this whole side to be 0. So what we're going to do, we're going to bring the negative 10x over and bring the negative 21 over, of course, using inverse operations. So we're going to add 10x to both sides. Okay, let's split this up so we can see it. And then add 21 as well. Okay, so that's going to give us on the left side x squared plus 10x plus 21 equals negative 10x plus 10x makes 0. Negative 21 plus 21 makes 0. So the right side is entirely 0, which is what we want. Okay, so we converted to standard form, something x squared plus something x plus some constant equals 0. Now we're going to factor. To factor this, we need to take a look at the factors of 21. We want something that multiply to 21 and add to 10. Okay, so we got 21 times 1, 7 times 3, and those are the only factors of 21, so this one's nice. We don't have a whole bunch of factors to choose from, so we're going to use the 7 and 3 pair. Everything is positive in the equation, so our factors are going to be positive, so it's going to be x plus 7 times x plus 3 equals 0. We'll use the zero product property, setting each individual factor equal to 0. Okay, so x is negative 7, and x is negative 3. All right, so I'm going to erase number 1 because we don't have a lot of space for number 2. All right, so for number 2, we want this right side to be 0. So to get it to be 0, I'm going to add an x squared. I'm going to move it over to the other side with opposite of negative x squared. Okay. So that's going to give me negative 5x plus 4 plus x squared equals 0. Okay, great. We have the right side set equal to 0, but we need to rewrite the left side so that it's in standard form. Ax squared, the thing with the x squared comes first. So x squared plus bx, so we want the term with the x to come next. That's going to be a minus 5x. And then we want our constant to come last. All right, so take a look at the factors. 4 times 1 and 2 times 2. So the pair that we can make a 5 from is the 4 and 1. In order to make it add to negative 5 and multiply a positive 4, both have to be negative. So it's going to be x minus 4 times x minus 1 equals 0. can go x minus 4 equals 0, x minus 1 equals 0. So x is 4, and x is 1. Okay. Number 3 is different. Okay. We do want this to be 0, but we need to simplify this first. So we need to expand out x plus 1 squared. So we have 2x squared plus x minus 1. Instead of x plus 1 parentheses squared, I'm going to write that as x plus 1 times x plus 1. Okay, let's clean it up. So the left side still 2x squared plus x minus 1. Right side, remember multiplying binomials, x squared plus x plus 1. And when we combine like terms, this is 2x. So we have 2x squared plus x minus 1 equals x squared plus 2x plus 1. Okay, so we want to get rid of everything from the right. So I'm going to subtract an x squared, subtract a 2x, and subtract a 1. Okay, so the right side now is just 0, which is what we want. So 2x squared minus x squared is x squared. X minus 2x minus x, and then minus 2. Okay, so the only way to make 2 is 2 times 1. All right, so we want to add to negative 1 and multiply to negative 2, meaning we're going to need a positive and negative somewhere. So let's see. I want to add to negative 1, so I'm going to make the 2 negative. I'm going to make the 1 positive. Okay, so negative 2 plus 1 does make negative 1. Negative 2 times 1 does make negative 2. Equals 0. Use a zero product property. I'm going to do this over here. You know, x plus 1 equals 0, and x minus 2 equals 0. So x is negative 1, and x is 2. Okay. Number 4, we're also going to have to expand out a binomial. So this is x plus 3 times x plus 3. Okay. I'm going to leave the right side for now and just expand this out because we don't need to keep rewriting the right side. So this is x squared plus 3x plus 3x plus 9. So we got x squared plus 6x plus 9. Let me get rid of this line. Equals 2x squared plus 10x plus 12. Okay, so we want the right side to be 0. I'm going to subtract 2x squared, subtract 10x, and subtract 12. So we've got negative x squared minus 4x minus 3 equals 0. Now when we solve this, we don't want this negative we don't want to have this negative in front of the x squared. Otherwise it's going to be nasty to factor because remember we want our beginning terms to both be x, and x times x makes x squared, not negative x squared. We could factor like this, but there's a trick to avoid that. So to avoid that, we can multiply the whole equation by negative 1. Remember, we're not really changing everything, if anything, if we're multiplying the entire equation. This is going to give me x squared plus 4x plus 3 equals 0. Okay, well, this isn't bad to factor. The only way to make 3 is 3 times 1. Everything's positive, so it's going to be x plus 3, x plus 1 equals 0, x plus 3 equals 0, x plus 1 equals 0, x is negative 3, and x is negative 1. Okay, last one. So here we have to expand out the right side. This is x plus 7 times x plus 7. So that's x squared plus 7x plus 7x plus 49. So that's x squared plus 14x plus 49. Now the left side, 2x squared plus 3x plus 79 equals. All right, so we want the right side to be 0. We'll get rid of terms. Minus 14x, minus 14x. And then minus 49. Okay, so we have x squared minus 11x, and then plus 30 equals 0. So for 30, we have 30 times 1, 15 times 2, 10 times 3, and 6 and 5. So the pair that we can make an 11 from is going to be 6 and 5. So we want them to add to negative 11 and multiply to positive 30, so they're both going to be negative. So it's going to be x minus 6 times x minus 5 equals 0. Again, if you're not sure that you factored correctly, multiply out the check. X minus 6 equals 0. X minus 5 equals 0. So x is 6 and x is 5.